if we start to think about placental function and dysfunction, gestation length is kind of an indicator of normal placental function. And what we observe with animals that are heat stressed is they tend to calve in 4 or 5 days earlier than animals that are not heat stressed. So there is a sort of 30,000 foot indicator that something is off with placental function with heat stress. And I'll show you some more evidence of that as well. But in terms of our switch study, pretty clear that the animals in the heat stress treatment had a reduced gestation length and a reduced dry period length relative to the animals that were cooled. What was surprising, and this is where we started to see things that we weren't expecting so much, was that both of the switch groups also had a reduced gestation length and a reduced dry period length relative to the cooled cows, but they weren't any different from the cows that were heat stressed the entire time. So they weren't any different if they were heat stressed early, heat stressed late, from the animals that were heat stressed for the entire dry period. So again, this is an early indication of differences in placental function. That placenta is doing other things, though, as well as sort of supporting that calf's development. We already talked about this a little bit. Just an example, estrone sulfate, one of the estrogen metabolites, is reduced in animals that are heat stressed, represented on that dashed line, versus animals that are cooled in late gestation. So that's an indication that we're decreasing the stimulus for potential stimulus for mammary development in the animals that are heat stressed versus those that are cooled. And just another indication of placental dysfunction with heat stress. Some more evidence. The PAGs, different PAGs are produced by the placenta at different times during pregnancy. In the case of PSPB, it's usually elevated late in gestation. Function doesn't really matter. We know that it's only produced by the placenta. That's the only place it comes from. What's important to this discussion is that heat stress reduces output of PSPB. So just another, relative to cooling. So just another indicator that those animals are experiencing placental dysfunction under heat stress. And probably as direct and as easy a way to sort of provide evidence that there's placental dysfunction in those heat stress cows is represented here. So on the one tray to the left are all the cotyledons from the placenta of an animal that was heat stressed late in gestation. The two trays on the right are all the cotyledons from an animal that was cooled during late gestation. So, of course, the cotyledon is the fetal side of the placentome. It links up with the caruncle, which is the maternal side, and that's really the connection between mom and fetus, and is then where all of the nutrients are going to be transferred, where gas exchange is occurring. And so pretty clear that there is a significant effect on placental morphology with heat stress in late gestation versus cooling. It's about a 40% reduction in cotyledon number in animals that are heat stressed versus those that are cooled.